A blockchain is a link of records, information, or blocks stored publicly and in chronological order. These records are referred to as a digital ledger and are linked in a manner that it's impossible to hack, edit, or trick the system. The idea was introduced by a person called Satoshi Nakamoto to timestamp digital documents and effectively prevent tampering with records. Blockchain technology combines decentralization, encryption, and openness to create a system that's both open to everyone with access to it and difficult to hack at the same time. I'm going to explain the definition in 3 parts. First of all, decentralization here means that control of the stored information is distributed amongst the users, and not one person or entity has sole custody over it. This effectively creates more trust amongst users and tackles the vulnerability attached to centralized transactions, where anyone who is or has hijacked the control of the system storing the information can easily tweak the system to gain access to users' data and do with it as they pleased. Take banks and other centralized financial institutions, for example, which store their information in a central location, which makes it easier for hackers to penetrate. But that isn't the case with a blockchain, because a tweak in the structure of the blockchain is only possible if there's a consensus mutual agreement amongst the network of computers storing separate but identical versions of the blockchain. Let's say 4 friends own a document, but only a copy of it is available in the custody of one of the friends. If the person makes a change in the paper without the knowledge or permission of the others, there's no way they can know about what has transpired. But if it is made into 4 copies and kept in each of their possession and one person makes a change to theirs, the disparity can be easily detected. That's how blockchain works. Secondly, to ensure the security of the blocks, the information contained in the blockchain is encoded by using a cryptographic algorithm called the SHA-256. To change or even gain access to this information, depending on the blockchain, you need to have 2 keys. Private and public keys used to generate a secure digital signature matching the correct records block in the chain. The private key is known only to the sender and is also used to confirm the legitimacy of the origin of the transaction. The public key is also used to identify the user, but is shared publicly during a transaction on the network. These keys perform all kinds of digital transactions over the public network. Now, imagine that the information contained in the document used as an example is so sensitive that all 4 friends decided to keep their copies in safe boxes requiring 2 keys, one personal key for each individual and a public key for the group. But these keys have to be used at the same time before you can open one of the boxes. It's apparent that if one person wants to open their box, they would need the permission of the others to get the public key. If the keys do not match, the box remains locked. The third part of the definition is openness. All of this communal information is cataloged in a shared ledger over a peer-to-peer network where it's easily accessible and anyone can monitor the file for changes. Transactions made on the blockchain network are immutable. That is, once a piece of information is recorded, modification is not allowed. Let's break it down even further by looking at one block. What is one block? What does it contain? A block contains the information in a transaction that has to be validated. It consists of 4 components: previous hash, data, nonce, and hash. A previous hash is an attribute or link connecting a new block with another block in a chain. All of the information in a block is added to every newly created block along with the new data. Data is simply the details showing the address of the parties making the transaction and the agreed amount. A nonce is a random or semi-random number generated for a specific use. In blockchain, it is to vary the hash value output using proof of work to verify the transaction. The input value of the first 3 components produces an output value of fixed length called hash. The hash is the digital fingerprint of the new block created. That is, it's the identity of the new block. Before we end this video, let's look at a few situations where we can use blockchain technology. You can use blockchain technology for anything that requires a secure record. Most people confuse blockchain with Bitcoin by assuming it's interchangeable. That's a misconception. A blockchain is a transactional means, while Bitcoin is a cryptocurrency exchanged between users via blockchain technology. It has become apparent that the applications of blockchain technology can go far beyond just cryptocurrency transactions. I'll show you some situations where blockchain can be applied. Cryptocurrency. Let's start with cryptocurrency. Cryptocurrencies like Bitcoin, Litecoin, Ethereum, and Doge are exchanged using blockchain technology for secure, quick, and easy transfers at rates cheaper than what banks would have charged you if you were to use a bank for such a transaction. Government records. You can also use blockchain to store government records like marriage certificates, health records, business registrations, tax records, etc. Governments like South Korea and Dubai are already adopting this method of safekeeping. To track goods. Another application of blockchain technology is to track goods passing through the supply chain from producer to distributor. Walmart started looking into this technology after an incident in 2020 where a batch of lettuce tested positive for E. coli and a recall was issued. If the supply had been through blockchain, it would have been easy to pinpoint the particular batch that was bad instead of having to recall every lettuce sold during that period. In the same vein, if you are looking to buy a diamond and are skeptical about whether it is genuine or not, blockchain technology can track the movement of the diamond up to where it's mined. Other uses of blockchain technology include tracking patent rights, securing intellectual property, enabling smart contracts, tracking a patient's health records, transparency in charities, etc. Is there anything we didn't include in this video? Share with us your thoughts, and don't forget to give this video a thumbs up and subscribe to the channel for more videos such as this one. See you soon!